Rich, I'm just curious, how much water are you using when you knock this thing down?
This one, the last one we did was like 4 gallons, 4.2 gallons of water. This one was under 4.
Okay, so when you're
Under
saying
4
no
gallons.
additives, no foam.
No foam.
Now, how come you didn't use foam on this one?
Well, because the way the system's designed, it's taking water and breaking it down the way it's supposed to do, and it's down to micro drops, small droplets, so that it absorbs more heat. So there really is no need for an additive when you have water coming out of a nozzle. It's in the micro drops. Our standard nozzles we use today, or fire departments use today, they have large drops. They don't absorb much heat.
Gotcha.
That's why you
so
see
on a typical vehicle fire, how much water are most guys using?
I would say it starts at about 100 gallons, maybe 80 gallons,
Okay.
but nothing less than that. A fully involved vehicle, you can get up to 300 gallons.
Gotcha. And you're saying you use only 4 gallons
4
with
gallons.
this thing?
That's all we use. And
I noticed you're using the nozzle tip on the windows. How does that work for you?
the strength of this nozzle is that it provides safety. It's long, so it keeps me away from hazards. I can hide behind some of the body of the vehicle, not in front of the glass. And it's so strong, I can break windows with it. I can break all of the windows except for the one in the front, because the front is designed to take impact from crashes. So we concentrate mainly on the sides and the back.
Gotcha.
And it has no problem going, especially when it's heated up a little bit, it breaks right through it, and it's instant water right after that, and you start suppressing the fire.
Gotcha. What do you foresee most departments using this for? Is this just for vehicle fires only, or what do you?
You know, Bart, I see this for every aspect of every fire we go on. Whether it's initial attack on a structure from the outside to change the atmosphere inside so we can go in and do our job at a lower heat. Car fires, you get no water runoff, and that's where we want to protect the environment. All of our stuff now goes down to the drain and into the ocean. There's no water runoff with this system at all.
Gotcha.
There's just none.
Gotcha.
Okay, so I see it in every aspect: wildland, structures, vehicle fires, miscellaneous nuisance fires. And even if it's not used initially, then it should be used in some point in time of the fire, because you're not going to need large water to overhaul, to mop up. Bring this out, it's going to reduce water usage. We're in a water shortage. It's going to reduce injuries, firefighters, because we have all kinds of injuries with heavy lifting, moving hoses around, and we just don't need it anymore. And the big thing is that we don't need the exposure. Cancer is on the rise, and we're exposing ourselves too much inside and around stuff. And one thing we haven't improved on is the capability of what water is going to do for us. This system does that.
Okay.
Absolutely.
Well, thank you very much. I have one other question, though, Till, on your nozzle tips. Is it just one spray pattern? Is it just a fog pattern?
You have about a 30-degree fog, which is about a 30-foot reach, and then you have a straight stream, and that's about 50 feet.
Okay, and you were using the fog,
I was
correct?
using the
Yes.
fog the
Yeah.
whole time.
Okay.
So if you wanted something to reach out and cool it down that the fog won't get to, use the straight stream. You know, we use that a lot on wildland fires. To get ahead, we kind of shoot in front of it to knock it down and follow it up with a spray to put it out.
Okay.
So simple stuff, same thing we do with our big hose now, but just a lot easier to do with this one.
Gotcha.
More efficient.
Well, thank you. Very
Okay.
impressive.